Good day, friends. Today we are going to see the fixed DCP extinguishing system on board ship. In this coming video, I am going to describe about the working principle of fixed DCP system as well as the other associated parts also. Okay, so let's go on and see the fixed DCP extinguishing. First, we will see over here why dry chemical powder system is required. As we know that this is basically required on board gas tankers, because this is the fire extinguishing medium which is having the technology of breaking the chain reaction, and very quickly it is going to extinguish the fire which is being ignited by the gas. So here we will see that in the event that the flammable gases are being ignited, extinguishing solutions that can be deployed quickly and effectively, which minimize the risk of the personnel and environment. So basically, if you have a solid fire, you can easily fight it. If you have a liquid fire, that is also possible. But in gaseous, it is all around. So the best way is the starvation, means if you shut off the supply of the fuel or the gas. Otherwise, you have the DCP system. DCP fire extinguishing system breaks down the chemical reaction with the fire, and it suppresses the flame almost immediately. This is the best part of it. So the personnel of the onboard ship, they will also be safe, and environment is also safe. Ship carrying liquefied gases, some of the chemicals and specific agents in the bulk which is being carried in the chemical carriers are equipped with the fixed DCP. Okay, now we will see about the key features of the DCP system. What are the key features or the properties, you can say, of the dry chemical powder? Okay, it is very effective, non-toxic, alternative, and it is harmless to the people and environment. That is the first part. Extensively and independently it is being tested, and this also complies with the regulatory requirements. Okay, proven times release and capacity capabilities are also there. Within the less time period, it is going to release it and extinguish the fire. Can be deployed by handheld hoses also. That facility is also being available. Fixed monitors also, and combination of both also up till 190-meter pipe and 33-meter hose, with a capable of handheld pistol up to 140 meters pipe for the monitor. These are the specifications as per the length which is required on board the gas tankers requirement. This powder penetrates into the smallest and even partially covered locations also. This is also the part of it, because it is going to penetrate inside, and as soon as it reaches the location of fire, it can break the chain reaction and extinguishes the fire. Okay, tested in the minus 28 degree also for the long pipes. Okay, so that means even in your minus temperature or sub-zero temperature, this is also going to help us. Okay, and it will be stabilized. The chemical used in the principle is sodium or potassium bicarbonate. So what is the DCP powder basically made of or consist of? This is your sodium or potassium bicarbonate. Now we are going to see about the benefits of DCP system. What are the basic advantages? Okay, dry powders are stable at both low and high temperature. It's up to 50 degrees centigrade. Dry powders are not toxic in nature, but due to the size of particles, which is approximately 10 to 50 microns, temporarily breathing difficulties also may occur. So when you are using it, you must have been with the mask and complete maybe a CBS system. Okay, and personnel may stay clear of the jets to avoid suffocation. Means from the long distance you can utilize the jet for fighting the fire. Modular units provide the flexible solution, reduce pipings routes, and eliminates the need of distribution pipe. Okay, so when we will see the diagram of it, we can see that the coil of the pipes are also there with the gun, and you can have the your gun also, which is fitted on that complete on decks. Okay, components can be installed on the skid for reduced installation time and cost. That is also there. Various additives are also mixed with these chemicals to improve the storage, flow, and the water repellent characteristics. Means basically with the DCP problem is that you will have the caking problem, or long time it is not being used, then caking problem. So some additives are also being used so that it become free flow always. Okay, and it will have the easiness in the storage part of it. SOLAS rules, when we talk about the IGC code, when we talk about the IBC code, requires that the dry powder system protects the entire deck area. So coverage has to be complete deck area, cargo manifold, and the connections area from the fixed monitors. In addition, the system should be capable of supplying the dry powder at any part of the cargo deck from at least two sources. The requirement says that at least two sources from which it can supply the DCP to all part of the cargo area. Either it can be from handheld hose or hose line, or from the DCP monitor itself. Okay. Okay, now we are going to discuss about the system description and configuration, how actually it is being done. Okay, so the DCP system basically comprises of the steel vessel or vessels, possible to have one container or maybe two also possible. Okay, the cylinder banks with the manifolds, distribution valves, and gas release arrangements, and on deck you will have the hose stations, monitors, pressure gauges, and the safety valve system. Okay, and nitrogen cylinders are there. Nitrogen is used as a propellant. Okay, and when it is opened at the control station, so what happened, the gas passes through the pipeline to the container and opens the required distribution valve. So you can select the basically the hose stations, and from which where you have the location of fire, you can open it, and accordingly the distribution valve will open. The same gas simultaneously opens the series of nitrogen cylinder also. So basically in the DCP control station, you will have the series of nitrogen cylinders that will also be activated, and the nitrogen will come out of this cylinder, and it is basically go to the your DCP container, and it from the nozzle, from the bottom side, it will go to the nozzles. I will show you this in the diagram also. The nitrogen gas releases from the series of nitrogen cylinders and enters into the container from the bottom side and build up the pressure inside the container complete. Okay, and when it reaches the required pressure, the main this valve will open, and the dry powder start flowing to the appropriate release station, and there the distribution valve is already open, which you have opened from the hose monitors, and the discharge of the dry chemical powder is constant until the most of the dry chemical powder is being. So you can see over here, I'm going to see this one, like this is something which is a hose station which you have selected, and this is the nitrogen cylinder, pilot cylinder over here, which you can open it, and you can see over there, this is the thing which is going to come and open this distribution valve assembly, and then from there this pipe, and this is number 6, which is your control manifold, and from there it is going to this puncture this nitrogen cylinders, and from the nitrogen, these are the nitrogen cylinders, and nitrogen cylinders, the nitrogen will go out, and through this is number 2, this is your pressure regulating valve, and these are the bottom part of the DCP container through which the nitrogen is being inserted into this container, and the DCP powder is being filled up till here. So this will, what it is will do, it will come as a jet and completely agitate the powder which is inside it, and then it will accumulate on top of this. This is something which is a vacant space. So here the pressure will build up, and once the pressure is being sufficient enough to lift up this valve, so this will be lift up, and through this you can see over here the opening of the number 5. Number 5 is your control cylinder or the control cylinder valve station. This is something which, and here also the same path is being followed, and this valve is being basically opened. So what happened, the nitrogen is completely pressurizing from top. Okay, this is completely pressurizing from top, and down below you have this pipe, or this valve is now open, so through that it will come over to here in this one, and as we have seen already, so this valve, this manifold valve is particularly open, so the DCP flows over here, and you can see this one, this is available to these hose reels and the gun is there and through which it can discharge. Okay, now you can see the description of it. Release of the system may be remotely operated from the release boxes, which I have just explained to you, utilizing the nitrogen pilot cylinder, and alternatively manual operated at the dry powder unit also, from bottom also possible. The propellant gas system is designed to contain sufficient nitrogen to maintain the pressure during release, as well as to clean the pipes and the handhold hoses after the discharge. That is also work of it. Okay, the other dry chemical powder container, if available, is brought into the operation when the powder from the first container is being used up. If possible, you have to then powder flows from the second container through the same distribution manifold to the appropriate release stations, and automatic closing of the valve within the system is also going to prevent backflow of the powder from the second container to the first one. Okay, here you can see the two containers. One container is over here and another container is over here. Okay, and the same you can see the local release station. Okay, this is your hose station with the gun, DCP gun over here, and remote release station is also there. Same, this is the distribution valve over here, and this is the thing, and these are the nitrogen cylinders. Okay, so here we can have the two part of it. One is the port side, one is starboard side, and you can have this two sections. Okay, so these two, once it will be utilized, another one can also be utilized. The handhold hose cabinet is delivered complete, mounted on a GRP FRP box. It is a closed cabinet, so that everything will be protected on the weather deck, and fitted with a release arrangement, trigger nozzle, and the flange connection to the supply pipe. Each hand hose line cabinet is suitably placed along the deck, and it is approximately 33 meter of the two cabinets. The hose length is 33 meters. Monitors are located to ensure the coverage of the cargo manifold on each side of the vessel. I told you, port, starboard, both the sides are being covered up. The location is like that. Release box are provided beside the monitors and in cargo handling stations. Now, some of the rules and regulations of the IMO. IMO regulations require the powder used to be based on the potassium sulfate, and that our testing is being carried out with the type of the powder. Okay, potassium sulfate offers better compatibility with the foam compared to the sodium bicarbonate. So when we talk about this, sodium bicarbonate is there when basically you will find the sodium bicarbonate in the portable extinguishers of the DCP. In this one, fixed installation, the potassium sulfate gives the better result if you talk about the compatibility with the foam system also. Okay, system can be used together. Okay, so when foam and this DCP both can be used together to fight the fire. Okay, the regulation also states that the type approval test must be carried out, and the same type of the powder that will be supplied with the unit test, and it is being staged. You can see over here actual system, the DCP powder which is being stored over here, and these are the nitrogen bottles which is there, and connected hose and pipelines, and this is the hose reel arrangements which is fitted on the deck, and the pilot nitrogen cylinder is also shown over here. Okay, so thank you all of you. I hope all of you have understood the working principle of the DCP system and some of the advantages of the DCP system. Thank you again.